Right, good afternoon all. Hope you're all well. Welcome to another session of network architecture. And today we're going to be looking at network standards and models. Now, I think we remember when we were introducing the module in our previous session, we discussed the whole concept of one of the most important aspects of a network being a protocol. And we defined a protocol as distinctively a rule or a procedure that governs communication across distinctive networks. So these particular standards, their main purpose, in essence, is to ensure that hardware and software that is produced by obviously the different vendors that are out there can distinctively work together. So it's all about just ensuring that there's standardization of architecture put in place, so that the different organizations that are responsible for creating, developing, designing technology can still have their products work with other institutions, just for argument's sake, if you want to look at it from a different point of view. So that's the reason why you literally can plug in an IBM keyboard to a Asus system unit to a Samsung screen, just for argument's sake, because there's a standard that is out there that tries to unify the whole concept of communication and connection, if you want to look at it from a different point of view, as far as your particular setups they are concerned. So it's important to understand that these standards typically come in two forms. You've got what they call a formal standard and a de facto standard. And the distinctive difference between the two is that with a formal standard, this one is literally developed by an official industry or government body. And typical examples of this is IEEE, as a typical non-profit making organization that is responsible for standardizing communications across your networking environments. And then you've got de facto standards that are non-official or unofficial standards that emerge in the marketplace. And a typical example of this would be Microsoft Windows, for instance. So Microsoft Windows is a product of one company and has not been formally recognized by any other industry. But obviously, you'll discover that a lot of individuals and institutions use this particular product, just for argument's sake. So you'll find that in communications, in communications industry, a de facto standard or de facto standards at large are often they often become formal standards after they have been widely accepted by the industry that's there. So that's the distinctive difference between your formal and your de facto as far as standards are concerned. And then you obviously have your standardization process, which literally is the formal process by which standards are distinctively developed. So there's three distinctive stages, obviously, that take place when you're looking at the whole concept of standardization. So I think let's see if we can quickly create our notes naturally as we go along here. So what we were just mentioning a couple of seconds ago is that as far as your standards are concerned, you've got what they call a formal standard. And then you also have what is known as a de facto standard. So what we were mentioning a couple of moments back is that your formal standard is developed by an official industry or government body, and then your de facto standard is an unofficial standard that literally emerged in the marketplace as far as the usage there was concerned. So when you look at the whole concept of the standardization process, like I just mentioned a couple of moments back, is just a process by which standards are developed. So you've got, if you look at the standardization process here, you've got three distinctive stages associated with this particular setup. So the first one you want to look at is the specification stage. And what's happening as far as this particular stage is concerned, naturally the first stage in which the actual problem is defined as far as your configuration is concerned. So it consists of developing and identifying problems to be addressed. That's what the specification stage is all about. And then the second one that you want to also look at is identification of choices. Identification of choices stage. And what's happening as far as this particular stage there is concerned, again, the second distinctive stage. And as far as this particular stage goes, it's a process in which potential solutions are now identified. So the first stage is identifying the distinctive issues that arise. And then the second stage that we've got on a screen currently is looking at developing potential solutions associated with the problems that were initially identified. And then the third and final stage there is the acceptance stage. And obviously what's happening with this one now is that a solution is now adopted into an actual standard. So whatever solutions were initially identified in the second stage are now distinctively incorporated as basic solutions that need to be adapted or adopted within the actual industry, and it becomes an actual official standard as far as your configurations would go. So it's also important for you to identify the organizations that obviously are responsible for creating these particular standards as far as your networking environments are concerned. So here we can mention these as standards organizations. And the first one you've got is ISO. And this is short for International Organization of Standards. And this particular organization is responsible for making technical recommendations about data communications. So that's their primary purpose, to just ensure that they recommend appropriate recommendations from a technical perspective that are used as far as data communication platforms they are concerned. And then the second one you also want to identify is the ITU. And this one is known as the International Telecommunications Union. Normally, you might even find other acronyms as ITU-T for the telecommunications group. So this is a typical organization that is obviously responsible for setting standards of the United Nations. Obviously, it's representatives of about 200 member countries that comprise of that particular ITU. And membership was originally focused on just public telephone companies in each country, but obviously now it seeks members amongst the private sector as well, as far as your generic telecommunications platforms they are concerned. Another organization that you also are supposed to familiarize yourself with is ANSI, ANSI, and this one is short for American National Standards Institute. And it's literally an organization that's obviously functioning in the US as far as the national system of telecommunications and non-technical standards there is concerned. It has about 1,000 members from both public and private organizations in the US there, but ultimately also works concurrently with ISO and the ITU setup. The fourth one, which you are familiar with, is the IEEE, which is short for Institute of Electrical and Electronics Engineers. And like we mentioned right at the beginning, non-profit making organization really that is responsible for standardizing things like wired communication or wired networking and wireless configurations across the board as far as your networking platforms would go. And then the last one that is relevant in this regard is IETF. And this one is short for Internet Engineering Task Force. And obviously, it governs the whole concept of how the internet operates. And you'll normally find that when it develops its standards, it normally creates what is known as the RFC, or the request for comment, which are documents in which formal standards are literally developed and published. Right, so those are your generic organizations when it comes to the standards associated with networking in that regard. Now, what these standards would do for you is just enable you to understand exactly what literally takes place when two computer systems are connected and data is being transferred from one particular computer system to the other and vice versa. And it gives you a holistic understanding of what the whole concept of networking is all about in that regard. And one of the very important models that were developed that obviously enable you to understand exactly what's happening with your networking environment is the OSI model. And OSI is short for Open Systems Interconnects. I think we can just place that in there, Open Systems Interconnect. And what's happening as far as that particular model there is concerned is obviously just, again, enabling you to understand what actually happens when communication takes place between two machines as far as data and signal transfer is concerned. So this particular model has 7 distinctive layers, right? And these layers are literally interrelated, right? So one particular layer would feed into the other, and vice versa as far as configurations would go. So the layers that you've got associated with the OSI model would be layer 7 here, which is known as your application layer. Then you've got the presentation layer. The 5th one is session. 4th, transport. The 3rd one is your network layer. And the 2nd one is data link. And then the 1st is your physical. All right, so these are the layers associated with your OSI model. And again, we're going to be discussing them in a bit more detail, just for you to understand exactly what's happening in that regard, how they function, what these particular layers do in terms of understanding the whole concept of how communication takes place between two machines within a networked environment. And normally you'll discover that when you're looking at the sending process, you're actually going down the model. So when you're looking at sending, you're actually going down the model. And then when you're looking at receiving, you're actually going up that distinctive model. And you'll obviously see in a moment why that particular relationship exists as far as your configuration would go. So I think the first one we want to look at is the physical layer and understand specifically what is happening in that regard as far as configurations would go. So you've got the physical layer, physical. Also known as layer 1. And this particular layer of the OSI model identifies the network's physical characteristics. Right. So remember, we've mentioned before in the previous session that when you look at your networking configurations and architectures, your network exists in both logical and physical formats. And we've mentioned that with the logical architecture, naturally you're looking at how the network functions. And then your physical is how the network seems, what you actually can literally see as far as physical connections or configurations between entities or nodes within your network environment. So the physical layer of the OSI model's main purpose is to deal with all the physical characteristics of your particular network. And typical examples of this would obviously include generic hardware, And what are we discussing as far as your hardware components are concerned? Naturally, all cabling. You can also even discuss connectors. So here, when we're discussing our connectors, naturally, what we are distinctively looking at as a typical example is your adapters or your network interface cards as typical setups that would typically be relevant in that regard. The other thing that you also want to discuss is your hub architectures. More often than not, you'll find that, remember, we mentioned that your hub is one of the very basic central networking components that you'll find as far as your configurations would go in that regard. You'd also want to even discuss the whole concept of bit streams, right? So the zeros and ones associated with the representation of data as far as your ICT configuration there is concerned would also fall within this particular layer as far as your configurations would go. And then the other thing as well that you would also want to define as far as your particular environments would go would naturally be the topology as well. So here, that's your hardware. And we also want to discuss the topology. And remember, we mentioned that your topology is literally the layout of your distinctive network. So the common topologies that you'd find, which we'll obviously discuss at a later stage as well, would be your ring, your star. You can discuss mesh topologies as well. Bus as typical examples, hybrid combination of two or more types. So the topology is literally the physical layout as far as your specific configurations would go. So you can also even discuss other standards in that regard, the Ethernet in terms of your high-level protocols that we discussed yesterday, Token Ring and Wi-Fi, are all examples of IEEE standards that also function within the physical layer as far as your distinctive setup there is concerned. So the physical layer's main purpose, just looking at all the physical characteristics of what the network is all about, the basic cabling, looking at the types of connectors that you've got, types of network interface cards, the actual physical layout of the network itself, which is obviously defined by the topology as far as configurations and definitions there are concerned. And then the second one, as far as configurations are concerned there in your OSI model, is the data link layer or layer 2. Right. And with this particular data link layer, its main responsibility now is getting data to the physical layer so that it can transmit over the network. All right. So responsible for getting data to the physical layer so that it can transmit over the network. And the data links layer's responsibility as well is for error detection, error correction, and hardware addressing. So obviously making sure that whatever data is being sent is done so in an appropriate fashion to avoid any discrepancies that might arise should that particular data be corrupted or distinctively jeopardized as far as integrity is concerned. So naturally, you'll discover that its main responsibility is just to make sure that it can detect any errors that might occur, can correct these errors, and also look at appropriate hardware addressing as far as your specific environments would go. So obviously, you'll find that the term frame in this particular setup describes the logical grouping of data at that specific data link layer as far as your configurations would go. I think what you'd also want to discuss in this particular instance is to look at the actual layout of what a frame would distinctively look like. But now, before we do that, probably let's look at the two distinctive sub layers of your data link layer there. And these would include what is called the MAC. We've discussed this before as the physical address as far as configurations would go. And remember, this media access control layer media access control. Its main purpose is naturally it deals with the physical or hardware addresses that are literally burnt into each network interface card that is out there. So the physical address, we talked about logical addresses associated with routing. The physical address is the one that you'll find on every distinctive network interface card. So obviously, we discussed firmware before in computer architecture. Every network interface card would have a ROM chip that has firmware incorporated in that particular chip itself that would obviously have the physical address associated with this particular network interface card. So every network interface card on the planet would have a unique address that obviously enables unique identification of devices at a physical level or at within the physical sense as far as identification within any given particular network there is concerned. So if you look at it from a different perspective, let's see if we can look at our command line here. All right, so if you look at your command line, remember we've discussed command-based interfaces before. What you want to distinctively look at, as far as your particular setups are concerned, there is the IP config command, which is short for IP or Internet Protocol configuration. So if you type out IP config /all. Remember, the /all, like we mentioned before, is a switch that is literally an option that is used with that distinctive command. If we hit enter, we can get actual configuration of connection that is currently incorporated as far as this particular machine there is concerned. What you want to concentrate on in terms of the physical address that we're discussing, or the MAC address that we were discussing a couple of seconds ago, is that particular section there. You find that there's physical address and it gives you that hexadecimal assignment as far as the actual address is concerned, because your MAC address is actually a 48-bit address as far as configurations would go. That is obviously then converted into hexadecimal assignment that you find on that particular screen there. So like I was saying earlier on, no two NICs ever share the same MAC address. Right, so you have complete uniqueness associated with these physical addresses that are literally burnt into the ROM chips associated with these particular network interface card. So if you look at that particular MAC address, the first literally 6 hexadecimal digits, which is the 24, FD, and 52 there, are identified as what they call the OUI, or your organizationally unique identifier. So you'll find that no other manufacturer can use this, because this literally identifies the manufacturer of the device or the manufacturer of that particular NIC. So you can call it for lack of a better example, a serial number associated with a specific manufacturer that is always the same across the network interface cards that they produce or they design or they deploy. So the 24, the FD, and 52, they would identify a specific manufacturer, and it would be the same across distinctive NICs that this particular manufacturer creates. And then you also find that the last 6 digits, which would be your 39, 1F, and 1A there, as far as the last 6 hexadecimal assignments, as far as your setup concerned, are the manufacturer's unique number for that network interface card. So those are the ones that you'll never find literally the same across any particular setup. And this particular portion is also known as, or portion of the MAC is also known as the device ID associated with your network interface card. So the first part, or the first 3 hexadecimal assignments there in that particular MAC or physical address, identify the OUI. which is also known as your organizationally unique identifier. It identifies the manufacturer of that particular network interface card. And then the last six hexadecimal digits there are identified as the device ID. And again, like I mentioned before, this is the manufacturer's unique serial number for that specific network interface card as far as your connection there is concerned. So whether it's wireless or bounded, the whole concept still remains the same in that regard as far as your specific setups there would go. So that's the first layer as far as your data link configuration there is concerned, or the first sub layer, if you want to look at it from a different point of view. And then the second sub layer is known as the logical link control, or the LLC. So you have the second layer as the LLC, which is distinctively short for logical link control. And its main responsibility now is to deal with error and flow control mechanisms. So its main purpose, as far as configuration there, is to deal with error and flow control mechanisms. And you'll discover that if you're looking at it from an IEEE perspective, it's also identified as the 802.2 standard as far as your configurations there would go. You'll discover also that this particular layer as well would have two sub layers in certain instances, and these particular sub layers would be identified as LLC type 1. And this particular layer is responsible for connectionless service on that particular LLC sub layer. Now, it's very important for you to identify that when we discuss connectionless architectures in networking, it doesn't mean wireless, right? Or it doesn't mean that there's no physical cable connected as far as your environments would go. Connectionless configurations, which we'll also discuss a bit more detail in a couple of moments when we look at the transport layer, is you don't have to wait for an acknowledgement from the receiver. Right? There's that generic assumption that since this particular device is part of the network, whatever message I sent, this particular device will get. So you don't wait for an acknowledgement from the receiver. Think of an acknowledgement as a delivery report when you send an SMS, just for argument's sake. In a connectionless environment, you just send the SMS. You don't wait for an acknowledgement or a delivery report to say, okay, look, that particular SMS that has been sent has been received or has been read, whichever way you want to look at it. There's just that general assumption that since I've just sent the message, whoever I'm sending that message to, SMS to, has distinctively received the message in that regard. And then you also have what they call connection-oriented communication, where you wait for an acknowledgement from the receiver to literally state that you've or literally show or indicate that they've received the message. So in that SMS example that I was given a couple of seconds ago, that delivery report that shows that that message has distinctively been received is a typical example of that acknowledgement, and is also a typical example of connection-oriented configurations. If you look at WhatsApp as an argument, if you send someone a WhatsApp message and you get the one gray tick, that's a typical example of connectionless communication, because you're just going to assume that, listen, yes, I've got the one gray tick, but they've got the message. So your general assumption is that they're going to get that message anyway, or they're going to read that message anyway. But when you look at connection-oriented, you get the two gray ticks, and then you get the two blue ticks. There's an acknowledgement that that particular individual has actually received and read the message that you've typically sent. So that's the distinction between connectionless communication and connection-oriented communication. Just always remember that connectionless does not mean wireless. There's always a misconception in that regard that the moment we start mentioning connectionless communication, we are talking about the actual link between devices in that regard. And then naturally, the second one that you've got in that instance would be LLC type 2. And arguably, that one now deals with connection-oriented service of that particular layer. And again, that's where that acknowledgement we were talking about earlier on comes into play. But obviously, we'll discuss that slightly more in the transport layer setup as far as your configurations would go. So the devices that you normally find now functioning within the data link layer would be your switches. Because remember, yesterday we were mentioning the fact that when you look at your hubs, they've got two main issues, which is obviously security, and security in the sense that any communication that takes place in a hubbed configuration, every connected device gets that communication. So there's no dedicated comms when you look at your hubbed architectures. The second thing is obviously the speed issue. The more devices you plug in, the less the speed that you get, or the more the speed is divided amongst the actual devices that you've got. So to alleviate that or those particular issues that are literally experienced with your hubbed configurations, your switches were naturally designed that obviously have dedicated comms and literally more secure or more intelligent, if you want to look at it from a different perspective, a more sophisticated device as opposed to your distinctive hub. And it also alleviates, like we mentioned a couple of seconds ago, those two issues that are normally experienced with hubbed communication. And your data link layer now starts working with these particular switches to work with the MAC address configurations we're talking about, and obviously to avail for appropriate communication between devices within your localized area network setup. So you've got a physical address that you're dealing with in your data link layer. But the moment you start working with routing, now remember, routing is literally mapping a pathway from sender to receiver. That is obviously the most efficient means of sending messages or sending packets from one particular source to the other. You now start dealing with logical addresses as opposed to the physical, which looks at the physical characteristics of the actual network itself. So if you look at the frame that I was discussing earlier on, remember, a frame is just a basic data packet that obviously has your header and trailer information and actual data that is being sent as far as your configurations would go. So you'll discover that the data link layer will also look at converting these data packets into frames, which obviously enables them to be sent appropriately across a specific network. So if you want to look at the actual design of what a frame would look like, you've got something along these lines. Hopefully you've got enough space here. So you've got something along these lines when it comes to your frame. So the first part is your distinctive header there. The second one is your destination MAC. So the second part is destination MAC address. The third part is your source MAC. So your source MAC address. And then you also have the destination address. So you've got a destination address there. You also have the source address. Hopefully this is legible. And then after all that, you've got the LLC header. So your logical link control header there. And then the actual data is now incorporated in that particular segment of your frame, right? After your data, you've got your CRC. And then naturally, you've got a trailer there that is just responsible for filling up that particular frame as far as configurations would go. So remember, CRC is short for cyclic redundancy. Check, and this is just a platform put in place for error checking, just to make sure that there's no corruption as far as the actual data that is being sent there is concerned. So it's more or less just a platform that is there to make sure that data that is sent from one particular machine to the other is received in its original format, if you want to look at it from a different point of view. So it's all to do with error checking. It's an error checking mechanism that is there. And the trailer, like I was mentioning earlier on, is just filling up your particular frame itself. So for instance, assuming that you're dealing with a frame that is supposed to be 16 bytes for argument's sake as a fixed size, if the data, your CRC, your LLC, so if all these, the header, your destination MAC, your source, your LLC, and the actual data and CRC probably get to, for lack of a better example, 13 bytes for argument's sake. You've got 3 bytes that are still outstanding in that fixed format. Your trailer's main responsibility is to fill up that space. That's generic what the trailer is all about. So this is what your frame would distinctly look like. You're discussing your data link layer configurations there. And it's important to remember that in the data link layer, you're distinctively dealing with your physical addresses, which is your media access control configuration there. So remember, a MAC is also associated with your physical address there. So your physical address. All right. So that's the first two sections there as far as your particular OSI model configuration there is concerned. And then the third one is the network layer. So your network layer now deals with logical addresses, right? And the typical example of a logical address is obviously going to be your IP, right? So that's a logical address. Your internet protocol is a logical address, right? And in essence, when you're looking at the network layer now, what you are distinctively defining and looking at, its primary responsibility is routing, all right? Providing mechanisms by which data can be passed from one particular network to the other. So the devices that you now start looking at in this particular setup would distinctively be your router. Right, so this particular device, like we've mentioned before, now enables you to connect to separate networks. All right, so the moment you want to connect to a network that is obviously without the confines of your own geographic space, you distinctively use the router. And that router's main purpose is obviously to look at proper routing and providing mechanisms, like I was saying earlier on, by which data can be passed from one particular network to the other. I think this is the reason why you'll find that when you want to connect to the net, you're using a router to connect to your ISP, as opposed to just a generic switch or a hub. This is where the whole concept of configuration there takes place. So responsible for addressing and obviously a delivery of packets in that particular environment. And if you want to look at it from a different perspective, your router or routing is distinctively the process of finding a path through the routers, connecting networks to the internetwork, so that distinctively packets can be delivered to to the correct network, and obviously to the correct computer system as far as your distinctive setups would go. So normally you'll find that if you run the IP config setup, your network, your router is normally also identified as a default gateway, because that's the one that is availing for connectivity to the external network as far as your specific setups there are concerned. So it's very important for you to take cognizance of configuration in that regard. So I think if you want to look at it from a basic perspective, we're also going to be discussing this again when we look at topologies, is if you've got computer systems, so what maybe 3 machines there, or maybe the two machines for the purposes of space. So these are computers that are obviously connected through a switch. That switch then connects to a router, and obviously that router enables connectivity to the internet. So that's your particular setup there as far as your configurations would go. So these are computer systems or nodes, and that's our switch. And obviously this would be our router that then enables connectivity to the actual internet space there that you've got as far as your particular setup there is concerned. So your network layer that just distinctively handles routing of packets from one particular computer to the other. As far as your particular setup there is concerned. And then if you want to look at it from a different perspective, as far as setups there would go, if we can go back and look at our IP config window here. Right, if you go back to your IP config window, you'll discover that when you're looking, instead of looking at the physical address now, in the network layer, you're now distinctively dealing with your IPv4 and your IPv6 addresses. So your IPv4 address there is listed as 192.168.0.105. Typical example of a private IP address as far as communication platforms is concerned. We'd obviously look at IPv4 and IPv6 separately as well, in order for you to understand what's happening in that regard. So you've got a 32-bit address in the IPv4 and a 128-bit address, which is now identified in hexadecimal format, which is IPv6 in that regard. Now remember, the whole concept of it being a 32-bit address is that you've got 8 bits representing each one of the portions that you've got in the IPv4 setup. So 8 bits for 192, another 8 bits for 168, another 8 bits for 0, another 8 bits for 105. That gives you the 32-bit address. And then with your IPv6 address, you now have hexadecimal assignments for the 128-bit configurations, because you've got 16 bits representing each of the 8 portions that are incorporated within your IPv6 configuration. So we'll have a separate lecture there in terms of IP version 6. I think there's already a clip for the IPv4 configuration. Please have a look at it on the channel. I think I'll send that through in terms of the actual link a little later on, for you to actually have an idea of what's happening with IPv4. And then we'll have a separate lecture discussing IP version 6, so that you actually understand what's happening with these addresses, why they're important, and how they assist with the whole concept of proper network configuration. And I'm assuming again that will also assist with the PoE and the 2 TOS that are relevant when it comes to assessment for this particular module. All right. So that's the third layer there for the OSI model. And then the fourth layer is the transport layer. And with this particular layer, you're now looking at, where is our slides there? So we now want to look at distinctively the transport layer. And its main function is to provide mechanisms to transport data between network devices. So primarily it does that in 3 distinctive ways. Again, error checking is incorporated here. Service addressing, as well as distinctively segmentation, as far as configurations would go. So in essence, its main purpose is just to deal with end-to-end issues, such as the actual procedures of entering and departing the network, and obviously establishing and maintaining logical connections of data transfer between computer systems that are incorporated there. So if you want to look at it from a different point of view there, we've got our fourth layer, which is transport layer. And like we mentioned before, its main purpose is just to look at the whole concept of end-to-end communication across configurations there. So it deals with flow control. If you want to look at it from a different point of view, its main purpose is just flow control associated with communication with, as far as devices within your particular setup there is concerned. So with this particular configuration, how it does that through 3 different ways. Let's see, right. So you got error checking. All right, which is obviously ensuring that data is correctly sent and received. And then you also have service addressing, which obviously looks at the whole concept of data being passed to the right service at the upper layers of the OSI model. And then the other one is segmentation. which is distinctively looking at blocks of data that need to be broken down into packets of manageable size. Remember, whenever you're transmitting data, it's not sent as a complete unit. It's actually broken down into bits and pieces for manageable transmission as far as your particular setup there is concerned. And literally that's what segmentation is all about as far as configurations would go. So we've got two main types of protocols that function in this particular setup, right? Or two main types of configurations that function within your transport layer. You've got what they call the TCP, which is short for Transmission Control Protocol. Transmission. Right, and this one is the one that deals with your connection-oriented platforms. So with this one, you're now literally looking at connection-oriented. And what we mean by this is that you need an acknowledgement by or sent by the receiver to literally confirm that they've received the message. So this is also associated with what is known as guaranteed delivery, because there's always going to be an acknowledgement that is sent by the receiver of your distinctive message. So there's a guarantee as far as the communication there is concerned. And one of the other things is it becomes slightly slower because before you send another message or before communication is established again, you need to wait for that acknowledgement. So that's where it becomes a bit I wouldn't say tricky per se, but there's a slight a delay in communication in that regard. Why? Because there always has to be an acknowledgement that is sent by the receiver of your distinctive message in that regard. But on the other hand, now I think it's brilliant in the fact that it's the most efficient type of communication you can discuss. Why? Because your delivery is guaranteed, as we had mentioned a couple of seconds back. Why? Because you always get that acknowledgement. If you don't get the acknowledgement, then there's an assumption that the message has not been received, and that message needs to be sent again, right, until an acknowledgement is received. So there's always going to be some kind of confirmation in terms of whatever communication takes place in that regard. And then you'll also have another one, which is now known as your UDP. And this one is short for user datagram. Oopsie. User datagram protocol. And then with this one now, you are distinctively looking at, this is the connectionless we were discussing a little earlier on. This is connectionless comms. And with connectionless, it's effortless, right? Or it's a faster type of communication that you've got there because you don't have to wait for an acknowledgement. And it's brilliant in terms of speed, but problematic in terms of quality or efficiency because there's no guarantee or you don't know whether that particular message that has been sent has actually been received as far as your specific environment is concerned. So this is also known as effortless communication. Right, so effortless communications or delivery is what the user datagram protocol is all about in that regard. So it's very important for you to understand the actual differences between connectionless and connection-orientated configurations that is there. So it's with connection oriented, it's reliable means of communication. With connectionless, obviously there's no response by the receiver, so it's not as reliable in that regard. So if you're looking at the actual features of the transport or the transmission control protocol there, you're looking at reliability, relatively slower, like we mentioned before, And then obviously packets are sent, are resent if there's no reception from the actual receiver. And then if you're looking at the features associated with connectionless platforms, there's little or no reliability at all. Faster communication on the other hand, but then obviously packets are not retransmitted because obviously there's no errors that are detected in that regard as far as your configurations would go. So the acknowledgement that we're talking about in this particular instance is normally identified as ACK, right, which is short for acknowledgement in your regard, which is obviously acknowledgement message that is sent by the receiving computer, like we mentioned before, in connection-oriented comms, right? And then the fifth one now we're looking at in terms of the actual layers is the session layer. So you might want to argue that when you're looking at it from configuration purposes. So I think if you go back to this year, you discover that the first three layers normally would work within the physical aspect of your machining mechanisms. You've got actual devices that are functioning in this regard, your routers in the network, your switches in your data link, your cabling and your hubs in the physical. And then the moment you go from session all the way to application, you're now dealing with it in the abstract sense on the non-physical part. And then your transport layer is responsible for connecting the two, the physical and the abstract or the non-physical, the software-based platform, if you want to look at it from a different point of view. So application, presentation, in session, normally within the software environment, network, data link, and physical within the dealing with the physical aspects of your communication, and then the transport layer linking those two entities as far as communications there are concerned. So when we're discussing the session layer, what you're now looking at as far as configuration there is concerned is that this particular layer is now responsible for initiating, maintaining, and literally terminating logical sessions between computers. Right. So remember that term logical, because logical now looks at the functionality of the actual network at large. So your session layer's main responsibility is to initiate the actual session, maintain the session for the time that's needed, and then terminate the session when it's no longer relevant or needed in that regard. As far as logical communication platforms there are concerned. All right, so that's what your main configuration there. And I think it's also important for you to identify that when you look at your data link, sorry, your session layer as well, it's also responsible for what they call dialog control, which is obviously determining which device participates in communication as far as transmission is concerned, obviously given the time and the amount of data that needs to be sent. So the time of the actual connection, or the time of the session, or the time of whatever period that you need, and then also looking at the amount of data that is obviously being sent across the devices there. That's what dialog control is all about. So if you want to look at it from a distinctive point of view here, your session layer's main purpose is to initiate, maintain, and terminate your particular session there, all right, or terminate communication as far as your configurations are concerned, all right? So this would be each logical session between machines. So terminate each logical session between your machines, right, or your computers, whichever way you want to look at it. So the main thing you want to look at the initiation, maintenance, and terminating, which will be your default go-tos. And then again, like we mentioned a couple of seconds ago, you've got that dialog control. And what we mentioned in this regard, as far as your dialog control configurations there is obviously determining which computer is sending and which is receiving at any given time. So just determination of which computer is sending and receiving, which computer is sending and which computer is receiving. So here we can say determination or determining rather which computer is sending and which computer is receiving. So that's what your dialog control is all about. Now, this also introduces the modes of communication or the way in which data flows as far as your particular setup is concerned. So the way in which data flows, you've got simplex, right? And with simplex, what you're looking at is data flows in one direction only. All right. So here with the simplex communication, data is flowing in one direction only as far as your configurations there are concerned. And then, so you can talk about this as you want to look at it from a different point of view. Broadcasting is a typical example of a simplex type of communication, right? You tune into a channel or a frequency and you get whatever signal or content, and you're not sending anything back. So if you tune into a radio station, for argument's sake, you're getting content from the radio station, but you're not literally sending anything back to the radio station in that regard. And then the second one is half duplex. And half duplex is in both directions, but not simultaneously. All right, so half duplex is both directions, but only one particular direction at a time. And a typical example of half duplex there would be walkie-talkies, for instance. You can also even discuss emails. You send an email, someone needs to read it first and then send back as far as communication there is concerned. And then you also even discover that in certain networking configurations, your LANs would work with half duplex, although some literatures might want to argue that a duplex would be your default go-to in that regard. So duplex now is in both directions simultaneously. So telephone conversation, instant messaging, these are all examples of full duplex configuration. So normally you might find that instead of the actual term duplex, some literatures would actually mention full duplex as a typical setup that is there. So this is all associated with the session layer as well in terms of communication and in that regard. And then the other layer that you also want to look at, let's see if we can insert a couple more slides there. Okay, I think that should be enough. So that's the session layer, and then we've got the presentation layer now, which is the sixth layer. So we've got the presentation layer. And then as far as this particular layer now is concerned, its main purpose now is to convert data intended for or received from the application layer into another format. So remember, if you're going down, you with the application layer, so assuming, if you want to look at it from a different point of view, we mentioned here that if you're sending, you're actually going down the layers, right? If you're receiving, you're going up. So if you want to look at it from a very basic point of view, let's assume you're sending a mail. Obviously, it means that you start with the actual content that you want to distinctively send, for argument's sake. So you've got different protocols that enable that particular connection, for lack of a better example, between the app that you're using and the actual content that you want to send. The presentation layer's main purpose now, as you're going down, is to convert that data into a format that the machine understands, or within the network platform as far as communication would go. And then your session layer naturally is providing the communication time frame between the two entities or the two devices. It's also looking at the whole concept of again, like we were mentioning earlier on, the dialog control, which particular machine is sending, which one is receiving. The transport layer's main purpose is to determine how that particular data is going to be sent or how that particular email is being sent. Connectionless, connection-oriented as far as configurations would go. Also looking at the error control that we were talking about earlier on. The network layer now is looking at, from a physical point of view now, how to route that particular message or how to route the data packets accordingly across the distinctive networks that you're looking at. The data link layer now is looking at the physical configuration associated with your device itself, and then you go all the way down to the bit streams, the ones and zeros, and the cabling and so on, when you're looking at the physical layer as far as a reception of that mail is concerned. Remember, when you're receiving, again, if you're looking at it now as a reciprocal process, you can't receive an email if you're not part of a network, right? Just for argument's sake. Or you can't receive a message if you're not part of a network. And how do you become part of a network, or how do you actually participate in a network? You actually have to be physically connected first. So that's where the physical layer comes in with the cabling, with the bit streams, with the network interface cards. Then you get the actual devices that provide for connectivity, like your switches. You get devices that provide for the proper routing, and so on and so on. So that's the reason why when you're going down the module, you're actually sending an actual, you're initiating communication, if you want to look at it from a different point of view. And then if you're receiving, you're obviously going from the first layer all the way down to all the way up rather to the seventh layer, because you have to start with the actual network itself as far as your particular setup there is concerned. So your main purpose of the presentation layer is to convert the data that is intended for reception from the application layer into another format to allow for appropriate communication in that regard. And if you want to look at it from a different point of view, it just literally formats the data for presentation to the actual user itself. So it accommodates different interfaces on different terminals or different machines or different platforms or different devices, if you want to look at it from a different point of view, so that application program need not worry about that particular data itself. So it's three main jobs for the presentation layer. Three main jobs for the presentation layer would be data presentation, the second one would be your data compression. And then the third, your data encryption. So these are the three main purposes of what's happening as far as your presentation layer is concerned. Obviously, with presentation, you're looking at data being sent to the recipient in a format that obviously the recipient can process. Remember, you don't want to receive something in machine language, just for argument's sake. So it's sent to you in a format that you can distinctively process there. Then with compression, obviously, this is just about shrinking large amounts of data into smaller pieces. I think we all are familiar with that process. And then what this would then enable for is data to be transferred a lot more faster across any particular type of network. And then with encryption, again, making data unreadable by unintended recipients. I think that should be familiar territory for all of you in that regard. And then when you discuss now the actually, the other thing that you also want to look at is applications cannot necessarily read conversations, obviously, that have been sent. So some of the common data formats that are literally handled by the presentation layer would include graphic files, or graphics files, so your JPEGs, your PNGs as typical examples, text and data, as well as sound and video. So your MP4s, MP3s, typical examples of some of the formats that are dealt with as far as the presentation layer there is concerned. And then when you look at the seventh layer now, which is the application, This particular layer's main responsibility now is distinctively to just to take requests and data from users and pass them to the lower layers as far as the OSI model there is concerned. So obviously there's a common misconception about the application layer is that it represents applications used in the systems, right? But it's not. So your application layer does not deal with a word processor, for instance. Your application layer is not dealing with a web browser or a spreadsheet, just for argument's sake. The applications layer's main purpose, it defines the process that enables applications to use network services, right? So let me say that again. When you're looking at the application layer, it does not represent applications such as a web browser, a word processor, a spreadsheet, for argument's sake. What it actually does, as far as network configuration is concerned, is to define the process that enables applications, right? Those word processors, those spreadsheets, to use network services. So that's what the applications layer's main purpose is all about. So allows that end user access to the network by providing a set of facilities in general for application programs. So it provides facilities for application programs. It's not the actual application programs themselves in that regard. So obviously 5 categories of services that are very common when it comes to internet users, more often than not, is obviously file services, email, network printing services. You can also even look at the whole concept of application and database services. So the most common, 5 most common, so if you want to look at it from a different point of view here, let's mention 5 most common categories as far as services are concerned that are used by individuals, right? Would include your file services, email, network printing, database, and application. So these are the distinctive services that you've got there. So here we can just mention services, so that we're all on the same page. Yeah. Right. So these are the common services. So obviously this is what is literally provided for in your distinctive setups. So protocols defined at the application layer now. So these are so you find that here we can now mention that the protocols that enable that the access to those 5 services that I was mentioning earlier on. So protocols, here we can just mention defined at the application layer. Would include there's a whole host. So you can talk about SMTP, simple mail transfer protocol. This again from computer architecture, if you remember the whole issue of emails. You've got a sending platform and then you've got a receiving platform. So SMTP is responsible for sending mail. You can also even discuss POP. POP3, Post Office Protocol, as a typical example. IMAP, these would obviously be used for receiving mail. So you can discuss IMAP 4 there. Remember, the 4 represents the version, so Internet Message Access Protocol. You can also even discuss FTP as typical examples of configurations. You can also even discuss HTTP, your hypertext transfer protocol, that protocol that links obviously access to web pages over the internet. You can also talk about RTP. There's a whole host of protocols that function within this particular setup as far as your. So here, I think we can rather say some, so that we know that this is not the only. Some protocols defined at the application layer as far as your particular setup there is concerned. So you can also even talk about the server message block. You can also talk about the session initiation protocol. You can even discuss, maybe let's just list them. Let's just list some more. So we're on the same page there. So you can also even discuss RTP, your real-time transport protocol. You can even discuss your SIP, session initiation protocol. You can also even talk about SMB. So there's a whole host there, right, which is short for server message block configuration there. So this is your this is typically your OSI model at large, right? You can also even discuss things like encapsulation, your trailers and so on as typical examples of configurations that you find. As far as your particular setups there would go, virtual versus horizontal relationships. As far as communication there is concerned, remember, a horizontal relationship when you're discussing the OSI model is just communication from one device to another device on the same layer. And when it's a vertical communication, then obviously from one particular layer to the other, above or below, as far as configurations would go. So what we mean is, if you're looking at vertical, is what we've looked at with the send and receive. And then when it's horizontal, you're obviously looking at devices functioning or distinctively at the same layer there as far as configurations would go. So that's pretty much that as far as your OSI model is concerned. You also even discover that as part and parcel of the OSI model as well, the TCP/IP model was created. So your transmission control protocol over the internet protocol, which was also identified as the Department of Defense model, which was literally designed or configured by the US Department of Defense, which has layers that link directly to the OSI model as well. So you normally will find there's a process layer, there's a host-to-host layer, there's an internet layer, and network interface layer as far as configurations would go. Then you will also even find the internet model. So there's a distinct relationship in that regard. So let's quickly look at that. They're pretty much one and the same in terms of functionality. So if you want to look at the TCP/IP model, so this is literally the transport layer over the network layer, if you want to look at it from a different point of view, right? Because that's your transmission control protocol over the internet protocol. You've got 4 distinctive layers in this particular setup as far as configurations would go. So you've got your process layer. And if you want to be specific, your process layer links directly to the application layer and the OSI model. Links directly to the presentation. And also links to the session. Session layer. And then if you want to look at the third, which is your transport layer, that also links directly to transport in the OSI. And then you've got your network layer. Network layer that also links directly to, actually, if you want more specific names, yeah, I think let me rather do this. Where is this? Yeah, layer. So you've got your process layer. This is actually the host to host. Host to host layer. And then the second one is actually the internet layer. right? That then links directly to your network here on the OSI. And then the first layer is known as the network interface layer. And this one would link directly to your data link. All right. So that's the kind of relationship that you've got as far as configurations would go. You also will find the internet model. And the only difference now is that your internet model will have a fifth layer, which is your physical. So your internet model will have the fifth layer, which is your physical layer that obviously directly then links to your physical layer as far as your configurations there is concerned. So if you want to look at the internet model quickly, what that would then distinctively look like, internet model is instead of your 4, you now have 5, which again, you still have your process. You'll have your host to host. The third one there would be your internet layer. Oopsie. Internet layer. And then the second one would be your network interface. And then lastly, you'll have a physical. So obviously, as far as communication again is concerned, so that application presentation session host to host would link directly to your transport layer. That would be your network layer that will then communicate directly to the data link, and that one to your physical. So that's the relationship that you've got as far as your internet layer configurations there are concerned. All right, but pretty much one and the same. If you've already gone through the OSI, these typically link directly to each other as far as communication there is concerned. All right, so I think that should be that for us. So what I'd want you to do is, I think from a research point of view, look at the whole concept of encapsulation. So let's look at the whole concept of encapsulation in as far as these particular setups they are concerned. Also discuss encapsulation, decapsulation as typical examples there, but otherwise I think that should be there. So I think what you can, and then also look at, I want you to also look at that the clip that has the IP version 4 discussion, so that the next time we've got sessions, I think that will be sometime next week, if I'm not mistaken, we discuss exactly how to configure a network accordingly. So with your basic research there, we've got so discuss encapsulation and decapsulation. And then secondly, I'd want you to go and watch that. Let me see if I can quickly incorporate the link here. 2 seconds here. All right, feel to use the chat space so long should you need to ask questions. While I just quickly get this link for you here. Where are we? Where are we? Where are we? Right. So yeah, so that's the link that we've got. But I think maybe that this would make sense if I send it directly to. I think this would make much more sense here, because this would then, if I send it directly to your through VC Learn. So once I'll send that through VC Learn. So I want you to obviously watch that, because this would distinctively discuss IPv4. And then we'll need to have a discussion on that in terms of a short exercise, so that we see the proper understanding of what's happening in that regard. But I think to make it easier for you to just click rather on that link directly, I'll send it via email, so that it makes more sense in that regard. And then just for us to revisit again. Let me put this up there. So just to remember what's happening with the OSI model there. This is what I was just mentioning earlier on, that we've got your send and receive, and then what you're also looking at is now your physical, your data link, and your network are the physical layers. Your transport layer links the two, and then you've got your application, presentation, and session layers that will fall within the software-based platforms as far as your specific setups there are concerned. And then the other thing that you also might want to take into consideration is, if you look at, again, short descriptions of what's happening in terms of these particular layers. We've got something along these lines. Let's see if we can size this accordingly. So that should go all the way up there. Oh, what's happening now? Let's see if I can resize this accordingly. It doesn't want to pay blow. All right, let's see. Hopefully this is legible. Okay, so got something along these lines. Yeah, hopefully that is now legible. Okay, so that's the whole concept of what's happening as far as your OSI model there is concerned. Again, with the physical layer, just the raw bit streams of a physical medium, defines the format of the data in data link, decides the physical path that the data should take. That's the routing we were talking about earlier on. And then transmitting data using either TCP or UDP, or connection-oriented versus connectionless, maintaining connections, and obviously controlling ports and sessions. Now, remember, with the ports we're talking about, these are abstract ports. So, for instance, if you look at the HTTP protocol, that's port 80. As far as configurations would go, same difference would go with HTTPS, which is the secure version of Hypertext Transfer Protocol, for argument's sake, which is port 443. And then you've got ensuring data is in a usable format. That presentation layer configuration we were talking about earlier on works in that regard. And then obviously, your application layer now deals with human interaction as far as network services there would go. All right, so I think that that covers that. I will send through the link for I'll send these notes as well, plus the actual link for the IPv4 session that I'd want you to go and look at before we discuss how to properly configure a network using IPv4, and then we'll look at IP version 6 in a different session there. All right. Let me see if I can quickly unmute for those that might want to speak. Right. Do we have any questions, contributions, and/or concerns? Again, like I mentioned before, you can also use the chat platform to communicate. Do you have any questions, concerns, or contributions from anyone? All right, so it looks like we're good. Thanks for attending. We'll see you in the next session sometime next week. Stay safe, keep smiling, be of good spirits. We'll see you in the next one. Cheers.